8.6 probability. What you should learn: find the probability of events, find the probability of mutually exclusive events, find the probability of independent events. So for example 1, find the sample space. So sample space just means like the possibility of all events. Like what are the possibilities that could happen here? So one coin is tossed. Well, we could either get heads or we could get tails. That's our sample space. 2 coins are tossed. Well, in that case, we could get heads and heads, heads and tails, tails and heads, or tails and tails. So our sample space is 4 this time. The first time there's only 2 things, right? Heads and tails. I'll put it like that so it's less confusing, right? You could either get heads or you could get tails. When we toss 2 coins, now it gets bigger. We have heads, heads, tails. We have all those different combinations. And then when we toss 3 coins, same idea. Heads, 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 tails, heads, tails, heads, tails, head, head. And we can also get all the tails ones. And then the same thing, 2 tails and a head. Tails, head, tails, head, tails, tails. So there is 8 possibilities here. So that's a sample space. You just list out all the possibilities, and then if I ask you, like, hey, what's the odds of getting all 3 heads? It'll be like, oh, 1 out of 8. So now they understand what a sample space is. It's about how you find the probability of an event. And in general, the probability of an event is just the number you want over the total number. That's it. Like my example here, right? If I was like, hey, what's the probability of getting 3 heads? Well, how many times did 3 heads come up? Only once. So it only happened 1 time. Out of how many different possibilities were there? 8. So 1 out of 8. So that's how you do probability. Now when you talk about probability is the likeliness of something to happen. So 1 is 100% it's going to happen. So there's no such thing as like 150% probability. Like 100% is it's going to happen. 0% it's not going to happen. So we only hover between 0 and 1 when we talk about probability. Where 50% is like same chance of happening or not happening. Okay. So find the probability of an event. 2 coins are tossed, what's probably that both land heads? So if we're not sure we're gonna do a sample space, right? We could get heads heads, tails heads, head tails, or tails tails. So there's 4 outcomes. So if I'm doing my probability, there's my total is 4, right? Want over total is what I always say. And what do I want? I want heads to land up, so both times. So that only happened 1 time out of 4. That'll be my probability. A card is drawn at random from a standard deck of playing cards. So a standard deck of playing cards has 52 cards. If you're not sure, there's 13 of each suit. So there's 13 hearts that are red, 13 diamonds that are also red, there's 13 clubs, which are black, there's 13 spades, which are also black. So what is the probability that is an ace? So out of the 52 cards I'm picking up, what's probably it's an ace? Now each card, there's an ace of each type, so there's gonna be 4 aces total. So you have a 4 out of 52 chance of picking up an ace, which reduces to 1 out of 13. So you have a 1 in 13 chance of picking an ace at random. Random selection. The number of colleges and universities in various regions of the United States in 2008 are shown in figure 8.15. One institution is selected at random with the probability that the institution is in one of the 3 southern regions. Okay, so we want over total. So we want one of the 3 southern regions. So I'm guessing they mean all the ones that say south on it. So we're just going to add up all the ones we want. And that's over all total regions. We have to add up all the rest. So it's going to be like 581 plus 304 plus 453. I'm going to put the rest. Like everything, right? We're going to have all of them. I shouldn't even say the rest. This total. Right? We're going to add all those up. And when we do that, on top we get 1,446. So 1,446. And on the bottom we get 4,347. That's our total. And then if we divide, we get 0.3 with a line over it. So about 1/3, 33%. That's right, it's just 1 over total. How about mutually exclusive events? So 2 things are mutually exclusive, but they have nothing in common. So that's a mutually exclusive. That means they have nothing in common. For example, if set A was 2, 4, 6, and set B was 1, 3, 5, and I was like, hey, what's A intersection B? So intersection, this means like what they have in common. Well, in this case, they have nothing in common, so it'd be 0. Likewise, if I had set A was 2, 4, 6, and set B was 2, 5, 9. If I said what's A intersection B, like wait, they both have a 2, so just 2. So if they have nothing in common, we call that mutually exclusive. Now in general, if you want to find probability of union of two events, so what's the probability of that A or B happens? The key thing, keep in mind there, it's or. Intersection is and. Union is or. We use this formula. And if they're mutually exclusive, then we don't need to put this part because it's 0, so you just use that formula. In general, I just always use this formula, and if they're mutually exclusive, I just plug a 0 in here. So one card selected at random from a standard deck of 52 cards. What's the probability that the card is either a heart or a face card? So I'm going to use this formula. Probability of A plus probability of B minus what they have in common. A intersection B. Now, a heart, there's 13 hearts in the deck. So probability of heart is 13 out of 52. Right, we want a heart or a face card. How many face cards are in a deck? Well, face cards are, there's a king, a queen, and a jack. All the ones that have a face. So there's 3 face cards in each one. So we have hearts, diamonds, clubs, and spades. So, and they each have 3 face cards. So we have 12 total. 12 out of 52. And then you gotta subtract off what they have in common. How many cards are also face? How many hearts are also face cards? Well, hearts have 3 face cards, so 3 out of 52. If you do the math, I get 25 minus 3 over 52. So we get 22 out of 52. That's the probability of getting a heart or a face card. Now keep in mind, it's an OR statement. So like it's like if I'm picking my next card, I'll be happy with the heart or a face card. It could be this. So you have 22. You have a 22 out of 52 of either getting a heart or a face card, because either one make you happy. Probably mutually exclusive events. The human resource department of a company has compiled data on the number of employees who have been with the company for very periods of time. The rest are shown in the table right here. An employee is chosen at random. What's the probability that the employee has 4 or fewer years of service? So we have to find all the number of years of service. We have to add up all these. So we need a total here. So we're going to add them all up. And we get 529. So that's all these services right there. So for A, 4 or less years of service, well, 4 or less is right there. So it's 157 over the total amount, right? This 1 over total. That'll be your answer. For B, 9 or fewer years of service, so 9 is right here. So we're going to add up both of these amounts. Right, 9 or fewer, we need 0 to 4 plus 5 to 9. So that's be 157 plus 89 over 529. Which is going to give us 246 over 529. Okay, next one. Independent event. Two things are independent if they have no effect on each other. So like tossing a coin and rolling a die. Right? It's because I toss a coin and roll a die. They're not going to affect each other at all. Those things are called independent. Rolling dice in general are independent. And the way you find probability of independent events, you just multiply them. It's kind of like the counting principle. If they have no effect on each other, it's just the probability of one times the probability of the other one. That's it. So let's look at an example here. A random number generated on a computer selects 3 integers from 1 to 20. What's probably that all 3 numbers are less than or equal to 5? So less than or equal to 5. So 1, 2, 3, 4, 5. So you have 5 numbers to do there. So for the first number I picked out, what's the odds is less than 5? Well, 5 out of 20. For the second number, again, this is doing it randomly, so 5 out of 20. For the third number, It's 5 out of 20. We'll put them all together. I get 125 over 0.0008. Okay, one last one. This is an application problem. 9. Approximately 13% of the adult population in the United States got most of their news from the internet. In a survey, 10 people were chosen at random from the adult population. What's the probability that all 10 got most of their news from the internet? Well, so if there's a 13% chance the first person got there. So like we're talking about the first person, right? What's the odds? Let me erase that. What's the odds that the first person got the news from the internet? Well, 13%, right? And then you can do that for the second one also, 13%, because we want all 10. So we're going to keep on doing that for all 10. So that's going to be the same thing as 0.13 to the 10th power. And whatever that is, that'll be our answer. And that's the lesson.